Why does metal feel colder than wood, even when they're the same temperature? Touch the knob. Instant chill. A small shock of cold jumps into your skin. But the wood, it feels fine. Same room, same air, same time. Logic says same temperature. Your skin says otherwise. Metal feels cold. Wood feels warm. This isn't magic. It's physics. The same rules govern cooking, and why sweaters keep you warm. Your skin is a live thermodynamics lesson. It comes down to speed, how fast heat moves. By the end, you'll see materials differently. Everywhere. Cold bench, warm mug, cool tiles. Same principle. Let's step through the looking glass. Into the realm of thermal physics. To decode the doorknob, we need the language of heat. Heat is energy, the jitter of atoms and molecules. Hot, fast motion. Cold, slower motion. There's no substance called cold, just more or less heat. Feeling cold means heat is leaving you. Your body runs hot. About 37 degrees in a cooler room. Heat flows from hotter to colder, never the other way on its own. Skin thermoreceptors don't read static temperature. They sense rate and direction of heat flow. Fast outflow, cold receptors shout. Heat flowing in, warm receptors fire. Temperature perception is a moving story, not a number. Metal and wood play by different rules, and your fingertips notice. Thermal conductivity, how easily heat travels through a material. Metal is a heat superhighway, wood is a country road. Copper, aluminum, steel, famous conductors. Metals host free electrons, tiny couriers that rush energy deep into the bulk. Touch metal. Electrons zip away with your heat. Insulators like wood, plastic, cork, plus trapped air in sweaters, slow heat to a crawl. In insulators, heat passes via slow molecular vibrations. A bucket brigade. Metal at room temp pulls heat fast. Wood sips it slowly. Fast loss makes your cold receptors yell. Two objects, same thermometer reading, totally different appetites for your heat. Thermal conductivity is the key that unlocks the illusion. Zoom into the instant your skin meets metal. Your skin is alive with thermoreceptors tuned to rapid change. A 15°C gap creates a steep heat flow gradient. Metal conducts fast. Your skin cools sharply at the touch point. Cold receptors fire a burst to your brain. The cold. Shock. Wood resists heat flow. The cooling is gradual. The signal is mild. A speeding car grabs attention. A snail barely does. Conductivity becomes sensation. Two perceptions, same temperature. A beautiful duet of physics outside and biology within. Let's prove it with a kitchen experiment you can do right now. Grab a metal spoon and a wooden spoon. Let them sit to room temperature. Touch metal first. Notice the crisp, cool shock. Now touch wood. It feels neutral, maybe warm by comparison. Your touch is a heat flow meter, not a thermometer. Try book versus metal paperweight, ceramic versus plastic, glass versus wood. Mass and heat capacity affect how long it feels cold. A massive steel block can drink your heat for ages. A thin coin warms fast, cold fades quickly. A smooth, flat metal surface maximizes contact. More pathways to lose heat. Rough textures trap insulating air, slightly softening the cold. Still, conductivity dominates. Small rough metal beats large smooth wood for feels colder. Metals conduct so well because of metallic bonding and a sea of free electrons. Energize one spot. Electrons spread energy rapidly through collisions. That's why metals excel at both heat and electricity. Wood, plastic, glass have bound electrons. Heat crawls via lattice vibrations. Phonons. Cellulose fibers and trapped air hinder heat flow. Natural insulation. Pans are metal to move heat fast. Handles are wood, plastic or silicone to protect your hand. Steel wrench, insulated grip, comfort and control. Wooden benches feel kinder in winter. Windows trap air or argon to slow heat loss. Every wooden handle, plastic coating, and double-pane window is physics serving comfort, and your body plays along with rapid, protective responses. Cold receptors fire and trigger an instant, local reflex. Tiny muscles narrow arterioles, vasoconstriction, to conserve heat. Less warm blood at the surface means slower heat loss. It mirrors what happens in cold weather. Protect the warm core. Skin cools, nerves signal, brain constricts vessels. An elegant loop. Flip the scene in a sauna. Both spoons are hotter than you. Metal now dumps heat into your hand fast. It feels hotter, even risky. Wood transfers heat slowly. It just feels warm. Metal isn't inherently colder, it's better at moving heat. Once you see the flow, you see it everywhere. This is Science Deeps. Stay curious.